So in tutorial 3, we will first talk about observation data, how to visualize and analyze observation data. Because in the previous tutorials and lectures, we only talk about gridded data using like the reanalysis data that we use in the tutorial 1 and 2, and some simulation data that we use in the lecture. But we haven't really talked about observation data, and it is equally important to look at observation data in atmospheric science. So we will talk about this in this tutorial. And the most important libraries for observation data will be the pandas library, which is a library used for reading and analyzing tabular data. Well, basically observation data is mostly in the format of tables. So we will mostly use pandas library to do the analysis. So let's get started. So just run this cell to import all the libraries, and let's go to the reading.csv file session. So CSV file is basically a file format for tabular data. And here I have provided an example data for you, which is in this directory. So when you use the read CSV function from the pandas, you will be able to read this file. So if you go back to the Jupyter server and you go back to find the data from tutorial 3 here, data for tutorials and tutorial 3 and ops data, you can see there are 2 CSV files, and you can see these are the structure of the CSV file. And they are tabular data, so it's better to use pandas to read these files. And after you have read the CSV file using this function, then you can display it. So I just comment these first, and then I display it. You can see there are, so the structure of a pandas data frame. Here, after you have opened the CSV file, it will become a data frame in here, in this variable. Yeah, because I assigned to this df variable. This is data frame. So this is a data frame object, and you can see there are rows and columns in this data frame. So it's very similar to an array. And then if you print this out, you can see the type of this df variable is basically this one. So this is a pandas data frame. And then if you type d types, like this is very similar to NumPy. NumPy, you also have a function like this to tell you the data types of the array. So in pandas data frame, you also have this function, and you can see the data type of these columns. So this is object. Well, pandas deal with string as objects. So this is actually string. And then you can see the temperature, and then the relative humidity is in the data format of these ones. So there are a few special things about the pandas data frame. So comparing to NumPy array only has index number to indicate the rows and the columns of the array. But in pandas data frame, you will have some labels on it. For example, you have a label for this first column, which is a date. And then you have a label for the other columns as well, the temperature and RH. So the special thing about pandas data frame is that you have labels on either, you can have labels for the rows as well, but we don't have here. So when you call out like maybe some of the elements in here, you can just call the labels of the columns or the rows. And here, because we want to, like we have 2 different data frames here, and we want to combine them together as a single data frame. So we can use this function to do it. So pd.concat. So well, although the index didn't change, but you can see here I combined the 2 data frame together, and it becomes this amount of row, that's 2,800 something. But if I only have the single data frame, it only has 1,000 or something. So it is already a combination of the two data frame here. So this one is the function to do it. And then if you have like more than 20 observation data files, it is not really a good method to like to manually specify each of the data frame and then combine it. I think you should use some maybe loops or some methods to make your work easier. So for example, in here, this is the OS library. So the OS library is used for some, it's used to mainly for some instruction deal with the directories and folder structures. So for example, here I want to list all the directories in this directory. I mean, list all the files in this directory. So it is a list directory function. And then in this directory, I have two files here. And this is sorting. And when you have so many things in here, you can use this sort function to make it sort according to maybe the numbers. And then in here, I use a for loop to open and help me to concatenate all the data frames together. So the codes are here, and basically I first create an empty list. And then this is the path of the data, the observation data. And then I loop over all the files here. So this is this one. So basically it's this one. So I just loop over these two elements in the list here, and then I read the file here. So so first of all, this is one thing. So this is a function to join the path of this directory and the file name. So the file name is here, and then it's loop over here. So basically, maybe I can here. And then after I join the path, I read the CSV from the file. And then this is a function to add elements into a list. So so I add the data frame here to this list. Yeah, this is very complicated, right? Not really complicated, but you may find it a bit confusing because those functions are linked together each other. So when I do this, you can see that I also have a concatenated version of the two data frame. So this is here. And then actually in the data frame here, this row is duplicated. When you see from the data here, so I open, oh, sorry, okay. So this one is this date, okay. And then when I go to the last row of here, you can see this. But in this file, the first row is also the same date time of it. So when you concatenate the two data frames together, they will overlap. So you will have a duplicated index here. So you just use the drop duplicates function. Then you can see the row in between. So this duplicated row will be removed from the function. So you can see the original is 2008. Okay, 2882, and then after I drop the duplicate, it will become 2881 rows. Okay, so and you can see the index here is from 0 to 144 something, but the total row is this one. It is because when you concatenate the two data frames together, they will remain their original index, and it will not change the index by itself. So you can reset index And after you reset the index will become 2A1. So it will reorganize the data here and reset all the index. So this drop equals to true argument is for you to, maybe I show an example that I didn't use this argument. So if I didn't use this argument, it will maintain the original index in a separate column and then use the new index as the new index. And if you don't want to keep this column, then you can just drop it. Oh, okay, so this function is, you need to run this function to move on because I want to post-process the data frame to this one. So I just assign this data frame to replace the original one. Okay, so similar to any array, like NumPy array or X array, you can use this square bracket to select the data. So for example, I want to select the column of temperature. So I just use this operator to call the temperature row, column. Then you can see the column of this temperature. Yeah, it's the same here. And very similar to X-ray, you can use the dot sign to call this labeled column. Yeah, this is, you should label the column first before you use this function, the dot function. And then, again, it's very similar to what we introduced in the NumPy array. We can use the slicing to maybe select the first 10 rows from the data frame, so the first 10 rows. And if you use the dot values function, it will help you to convert the data frame to a NumPy array. So this dot values function, you can also apply it to X-array data frame or a data set as well. Then you can convert the data frame or the data set to a NumPy array. And okay, so basically data manipulation is very much the same. So in X-array, we use .SEL and .ISEL to select the data according to the labels or the index. And in pandas, we use these two functions, .LOC, like locate or something, or .ILOC, maybe index locate something. And here, okay, I use the .LOC function to select the data. So the difference between the two is like, but if you use the .LOC, you can select the data based on the labels. But if you use .ILOC, you need to select data based on the index, based on this position. So yeah, this is the difference between the two functions. And for example, in here, I use the .LOC. Then I need to specify the labels. And this is actually also the labels because we didn't specify the labels of the rows and it automatically generates labels with numbers. So this is basically, okay, the first row is the 0 label, okay, the label 0, and the second row is like label 1 and so on and so forth. So this is actually all the labels for the rows. And then these are the labels for the columns, and I choose these two columns from the data frame. So you can see here, I want to select every 60 rows in the data frame. Then you can see here's 0, 60, and so on and so forth. And then I select only these two rows in the data frame. So here you can see the two rows here. And if we use ILOC, you cannot use the labels anymore. You need to use the position or the index position. So here I use this function to do it. I use this operator, and this is like colon and then 2, which means the last two columns. Yeah. Okay. The first two columns, I'm really sorry. Okay, the first two columns, because this is the end. Okay, it is indicating the end of the index. So this is the first two columns. Okay, and then if you maybe, for example, if you do it this way, it will give you an error because you only can use the index position in order to select, to use the function of ILC. So you need this way. Yeah, and this is for another example, like you select a single element from the data frame. So let's move on to the next section, which is about Boolean indexing. So, well, the mechanics is very similar. So for example, in here, I want to select the data that has temperature larger than 18, for example. Then I just apply a Boolean array here, which is the condition here. Then apply it to the whole data frame and select only the condition that fulfill this one. So for example, if you first print this, run this command, you can see this is like a data frame of true and false. There are some false in between, but you didn't see it. And then if you just apply this Boolean data frame to this data frame here, it will select out the data that fulfills the condition. So maybe I use something more obvious, like maybe 26.1. And you will see it only contains information, the rows of data that only has temperature larger than 26.1. So it's like 26.2 and then 4 and then, yeah,